Well, we're not going to worry about that already. Okay, let me look at this thing. Practice test.
Friday? So then sharpen our
No,
mind.
but then on Friday, I guess Friday would be good.
Friday, so then sharpen our mind on the Monday.
Yeah, but then I want to give it back to you though, so that you know that you're memorizing it wrong.
Oh, then Wednesday.
Whatever then, let's do it Friday, whatever. We'll do it Friday. So, Trig, speed quiz on Friday. So you know the identity sheet that we have here? It's gonna look just like the identity sheet.
Oh, really?
You just gotta fill it in. So it's gonna be like, anything on that sheet is gonna be fair game. So like, we're gonna have 20 of these. Cosine negative theta equal. Sine of pi over 2 minus theta equal. Cosine alpha minus beta equal. Tangent 2 theta equal. And then today we will learn half angle identity. So like sine theta over 2 equal. I'm gonna have 20 of these. Just all you gotta do is regurgitate. Except I'm gonna have cosine 2 theta equal.
Oh.
Because there's 3 of them, right? Remember I did it on the video, I derived all of them for you. Yeah? So if you just put the same one 3 times, you're only gonna get credit for one of them now. There's 3 identities. Have we memorized them yet? After doing the homework? What are we waiting for?
3/4 of them?
I'm telling you, because if you don't have these memorized for the rest of the course, and you take pre-calculus next year, memorize again, your teacher can give you speed quizzes too. And then you go to calculus in college, whatever, same thing. Okay, so cosine 2 theta, you're gonna have 3. In fact, tangent theta over 2 got 3 also. We're gonna learn that today. Okay, so that's what the quiz is. All you gotta do is regurgitate. This is just pure memorization. It's easy. Okay, where's the book?
48.
Yes. But you gotta give me at least 15 minutes for the lecture today. Otherwise what, you guys gonna read the book?
Sure.
I doubt it.
I'll hold you.
Okay, number 11. Come on! Okay, so cosine theta is equal to negative root 6 over 3. And what quadrant are we in? So again, you have to draw the triangle in the proper quadrant, otherwise it's all over but the crying right there. So, what quadrant is this if you're between pi over 2 and pi? This is like today's quiz too. You are in the second quadrant, and cosine is adjacent over hypotenuse. And then if you use the Pythagorean theorem, what is that going to be? 9 minus, it's going to be root 3 here. Do I have the correct signs? Yeah, because you got to go left, so that's minus, and you got to go up, so that's positive, and the hypotenuse is always positive. Okay, now what do you have to do? And you're going to have the same problem tonight, except you're going to do C and D. We just did A and B. So tonight you're going to have to, tonight, same triangle, just going to use a different identity. So what is A? Sine 2 theta and cosine 2 theta. Okay, what's the identity for sine 2 theta? There's only one. Okay, some people have it memorized, the rest of us just befuddled, yeah? You can't get around it. No matter where or when you take trigonometry, you gotta have these memorized. Okay, now look at that picture. What is sine theta? Opposite over hypotenuse. This is good practice for SAT. What is cosine theta? Adjacent over hypotenuse. Negative root 6 over 3. I can leave the simplifying to you, right? Like root 6 times root 3 is root 18, and you can simplify that, right? I don't trust you. So negative 2 root 18 over 9. Oh, how do you simplify root 18? That's 9 times 2, so 3 root 2, right? Over 9. But 3 goes into 9 3 times, so the final answer is negative 2 root 2 over 3. Okay, now cosine 2 theta, you have 3 identities. It doesn't matter which one you pick. By now, everybody has their favorite, but like I told you on the video, My favorite is cosine squared minus sine squared. You might not like that one, but I like it. So cosine squared minus sine squared. Okay, so look at this picture. What is cosine? Adjacent over hypotenuse. Sine is opposite over hypotenuse. See how it all boils down to SOHCAHTOA again?
Yeah.
So if you square it, you're going to get positive 6 over 9 minus square that 3 over 9, and that's equal to 3 over 9, which reduces to 1/3. Right? Yeah, 1/3. Okay, 62. So the key right there is what? What's the key? Draw the triangle in the proper quadrant. Okay, 62 and 63, are these proofs? You bet your pimpy they are. Okay, so 62. Now, like I said on the test, you could have 3 or 4, might even have 5 proofs. You better be ready for them. Sine cube theta plus. The reason why I assigned this problem, I just want to see if you guys remember your sum of cubes. And it looks like we don't. Okay, now, look on the left side. The left side of this, look, sine 2 theta. There's only one identity. What is it? 2 sine theta cosine theta. The 1/2 cancels the 2, so you just have 1 minus sine theta cosine theta. So somehow, we have to simplify that to that. Okay, now let's review Algebra 2. When you have a cubed plus b cubed, which is what that is on the top there, how do you factor that? Algebra 2a, people. A,
Squared.
no, plus b times a squared minus ab plus. This is like pulling teeth. Oh boy. Okay, so now that you know, we reviewed that. Okay, so how do I factor this? This is like a cubed plus b cubed. A plus b times, just follow that thing over there, a squared minus ab plus b squared. Oh my goodness. All over. So that's the reason why we couldn't do this problem. We cannot factor this one. Hey, this cancels this. That looks good. And then, hey, use somebody. What is sine squared plus cosine squared?
1.
That's 1. So you get 1 minus sine theta cosine theta. It's the same thing. Quite easily done. So again, what's the key step? You gotta, it's algebra, right? That's what it is. It's algebra. Okay, 63. Can we squeeze it in over here? Let's see. What is 63? Oh, how many people got this? Wasn't it beautiful? Chi? Was it beautiful? This is beautiful. Okay, if you don't have Kleenex, go get some, because this is going to bring tears to your eyes. No, you're going to get choked up, I guarantee you. This is one of the most beautiful proofs you will ever see in mathematics. This thing simplifies to 2, somehow. Okay, so again, what happens when you subtract fractions? You make a least common denominator, which is sine theta cosine theta. Okay, now what goes on the top? So this one, you got to multiply top and bottom by cosine theta. So sine 3 theta cosine theta. And then this one, you got to multiply top and bottom by sine. So you're going to get cosine 3 theta sine theta. So at the very least, that's what you should have done, at the very least, because all you did is make the least common denominator. But now you got to start going, hey, use somebody. That's like today's quiz right there. That's the identity for sine of 3 theta minus theta or plus? Minus. All over sine theta. You guys see that? Well, hopefully you did it on today's quiz. And then, what is 3 theta minus theta?
2 theta.
2 theta, so this is just 2 theta. And what is the identity for sine of 2 theta? We did it, this is like the third time we're doing it right here.
Sine.
2 sine theta cosine theta. And then you're going to divide that by sine theta cosine theta. Cancel, cancel.
And you get 2.
2. Isn't that beautiful? So beautiful. I see that like twice a year and I still get choked up. It's so beautiful. You guys don't see the beauty in that? Whatever. Just like when you watch, what's that movie I always cry when I watch? What's the one he got stranded on the island? Tom Hanks?
Castaway.
Castaway, I always cry at that movie.
What? Why?
No, like you know when he comes home, he comes back, and then his wife got married to somebody else because they thought he was dead. Wasn't that sad?
Yeah.
No, and then he went to her house. Never mind. But see, those are tears of sadness. This is tears of joy right here. You guys really don't think that's pretty? Okay, you know what? I'm gonna give this problem again on the test, and then you see if it's pretty. All right? Okay, today's lesson. How much time you got? Okay, pretty. Okay, so today's lesson we're gonna learn the half angle identities. See these last few here? See how it's half angle? See how it's theta over 2?
Yeah.
Half, we call those half angle identities. All right, so, okay, look at the time. Okay, I will derive one of them then. Do you guys even, like, the reason why I show you the derivation is like, so if you're stuck on a quiz or a test, you can derive it yourself. Did that happen today?
Yes.
Okay, I will do one. Okay, I'll derive the first one. Okay, but ultimately, you just have to have these memorized. Okay, to derive the half angle identity for cosine and sine, basically, you're going to use the double angle identity. Okay? You know what? I'm going to use x instead of theta. It doesn't matter what letter you use. I'm just going to use x instead. Now, cosine 2x, there's 3 identities, right?
Right.
Can you give me one? Cosine squared x. 2 cosine squared x minus 1. Everybody agree?
Yeah.
Okay, now watch. All I'm going to do is play around with this identity. Add 1 to both sides. Divide both sides by 2. Square root both sides. Okay, you know what? I'm going to flip these like this. So cosine squared x is equal to 1 plus cosine 2x all over 2. Square root both sides. So cosine of x is equal to plus or minus the square root of 1 plus cosine 2x over 2. You guys know why there's plus or minus, right?
Yeah.
Like when you go x squared equal 4, square root both sides x equal plus or minus 2, right? All right, there you go. There's the derivation. Except, Mr. Bart, that doesn't really look like that. I thought it says theta over 2 here. So what you do is, see, whatever angle you put here, this angle here is double it. See, that's x and that's 2x, right? So what if I make the substitution x equals theta over 2? So what if I change this to a theta over 2? Then that becomes twice that. So what is 2 times theta over 2? Theta. Boom, there's the derivation. That's the first one right there. Now, if you want to derive the second one, then instead of using this identity, you use this identity, and you just do exactly the same thing I did here. And then, once you have sine and cosine, how do you get tangent? You just go sine over cosine, that's right. And that's how you get the tangent one. But the tangent one, I just want you to show you. You know what? Let me list them all out over here because we're going to use them. So cosine theta is equal to plus or minus the square root of 1 plus cosine theta all over 2. Oh, this is over 2. Sine theta over 2 is equal to plus or minus the square root of 1 minus cosine theta over 2. Tangent theta over 2 is plus or minus, and it's going to be sine over cosine, so it's this over this. The 2's cancel out, and you get 1 minus cosine all over 1 plus cosine. However, there's two others. 1 minus cosine over sine, and sine all over 1 plus cosine.
There's multiple for tangent or just?
Got 3 of them. Just like cosine 2 theta got 3 of them, right? Tangent theta over 2 got 3 of them. So on the speed quiz, when you get the tangent theta over 2, you're going to have 3 of these now. Do not put the same thing 3 times, because you only get credit for 1 of them. Okay, so that's what you got to know for tonight's homework. Okay, right there. It's on the identity. This is the last of the, you don't need to memorize anything more than this. Okay, this is it. Okay, now what kind of problems are you going to see tonight? Okay, the first problem is they're going to ask you to compute a value like this. Compute the cosine of pi over 8. Okay, let's just start simple. You know what? I'm going to change that. Let's change it to 5 pi over 8. That'll make it more interesting. Now, what the heck is 5 pi over 8? Now, if you were to convert that into degrees, oh, let me think about that. Because pi over 8 is equal to 22.5 degrees. That's what it is. Okay? Because pi over 4 is 45 degrees, right? So it's half. What is 5 pi over 8? You got to times this by 5, so that would be 112.5 degrees. Is that right?
About,
Not about.
I think.
112.5 degrees. That's what it is. Am I right? Yeah, I'm right. Okay, because some of you guys just don't like radians, huh? Okay, now 112.5 degrees. Is there a way I can write that as a sum or a difference of two angles that you do know? Like when we had 15 degrees, like was that on today's quiz?
Yeah.
Yeah, didn't you go 45 minus 30?
Yeah.
So can you do that with this? Can you write that as a sum or a difference of two angles that you do know? No, you can't because of that 0.5 there. That's a problem. So that's why we have the half angle identity.
Oh.
So, in fact, a hint would be anytime you have over 8, you're going to have to use a half angle identity. Okay? So, this is what you do. Is 5 pi over 8 half of an angle that I do know? 5 pi over 8, that's half of what? You gotta be kidding me, people. This is arithmetic. 5 pi over 4. Okay, let's stare at that for a while. 5 pi over 4 divided by 2, which is like timesing by half, is 5 pi over 8. Okay? And is that an angle I'm supposed to know? Yeah. So tonight's homework, you are, maybe on the test I should say, use half angle identity so you know you're supposed to do that. Yeah? Okay, so applying the identity, so which one am I looking at? That one right there. So cosine of theta over 2 is equal to, you just regurgitate now, plus or minus the square root of 1 plus cosine theta, this is the theta right there, all over 2. Now, here's the tricky part. You see this plus or minus? That does not mean there's going to be a plus or minus in the answer. That means you have to pick which one it is. Is it the plus or the minus? Now, how do you know which one to pick, Mr. Park? Well, it depends on the quadrant of that angle right there. Now, where is 5? Here's your unit circle. Where is 5 pi over 8? I'll give you a hint. This is pi over 2 over here, which is 4 pi over 8. So where would 5 pi over 8 be? Wouldn't it be just a little bit more then?
Yeah.
Yeah, so it's in the second quadrant. And it's cosine of a second quadrant angle. Is it positive or negative? It's negative. That's how you figure out which one to use. Now, you might be thinking, oh, that's a minor thing, but no, on the test, this minus sign is going to cost you 2 points now. And if you have like 10 of these problems, well, you're going to have 10. If you have 3 of these problems, it adds up pretty quickly. Do not put plus or minus though, because if you put plus or minus, I'm going to take off 3. You have to pick which one it is. You have to commit to one. Now, cosine of 5 pi over 4. Is that a number I'm supposed to know? Yeah. Where is 5 here? Let's do it here. Where is 5 pi over 4? Right there. What is the x coordinate of that point? What is the cosine of 5 pi over 4? It's in the middle. It's going to be medium.
2 over 2.
But you got to go left, right? Negative root 2 over 2. Now, if you write this on your paper, this is the correct answer. So, on the test, if this is worth 5 points, should I give you 4 or 3?
3 of what?
No, you know what? On the test, there's going to be so many problems. I think each problem is only going to be worth 4 points. So if this was 4 points, you write this down, I would give you 3 out of 4 points because that's the correct answer. But then it's not simplified. So how do you simplify this? What do you do? So let's extend the radical. Multiply top and, again, when you have fractions within fractions, multiply the top and the bottom by the least common denominator, which is 2. So inside the radical, multiply top and bottom by 2. So you're going to get negative square root of, what happens if you distribute the 2 over here? 2 times 1? 2 times negative root 2 over 2. The 2's cancel. Root 2. And then 2 times 2? 4. But this 4 can come out of the radical as a 2, right? And there you go. This is your answer. Look, it's a plethora of 2's. Negative square root of 2 minus root 2 all over 2. It's a funky answer, yeah? I mean, you can punch that in on your calculator. Well, you wouldn't, I mean, if you have a calculator in real life, you wouldn't do all this, right? You just punch this in on your calculator, right? You can spit out the answer. Okay, so that's the first type of problem you're going to see in tonight's homework, just computing. So you're going to have to use half-angle identities. Okay, let's do one with tangent. Okay, what is the tangent of pi over 8? Or 22.5 degrees, if you want to change it to degrees. So like I told you before, anytime you have over 8, you're going to use half-angle identity. So this is what you do. Tangent of something over 2. What is pi over 8? Pi over 8 is what divided by 2?
1 times 1.
Pi over 4. And is that an angle I'm supposed to know?
Yes.
Yes. Okay, so now tangent theta over 2. You have 3 of these. Which one should I use? Which one is the best one to use? Should I use the first one? No, you really don't want to use the first one if at all possible. You know why?
Because you have to choose.
Because you got to choose which one to use. And then you got a radical. And then you got a fraction inside a radical. There's a lot of simplifying you got to do. So you don't want to use that one if at all possible. So it's either this one or this one. Which one do you think? Second or third? Why?
I think you don't know.
Exactly. Because it has only one term in the denominator. Because if you have a radical, isn't it better to simplify something like, I'm just making this up, something like this, when you have one radical, as opposed, if you have 2, then you gotta multiply by the conjugate, that's why, yeah?
Yeah.
So, if you don't know what I'm talking about, just use this one. It's the simplest to simplify it. So, applying that identity, that's 1 minus cosine theta, this is theta, all over sine theta. And then, do I know these two values here?
Yes.
Yeah, I hope so. Remember I told you all of trig is based on these values.
1 minus.
So here's pi over 4, right there, right in the middle. So cosine is the x and sine is the y. So what is cosine of pi over 4?
Root 2.
Root 2 over 2 now. I'm just going to tell you this right now. Instead of using root 2 over 2, it's better to use 1 over root 2. Now, if you don't know, of course you don't know when you're first learning it, but I'm telling you it's easier. In fact, okay, I'll tell you what. Let's just do root 2 over 2 because you guys don't know. That's okay, just one extra step. What is the sine of pi over 4? Root 2 over 2. Okay, when you have fractions within fractions, multiply top and bottom by the least common denominator. So what do you got? 2 times this. 2 times this, the 2's cancel out.
Root 2.
And then 2 times this, the 2's cancel out, and you get root 2, right? How do I get rid of a root 2 in the bottom? Multiply top and bottom by root 2. Because root 2 times root 2 is 2. Take this root 2 and distribute it. Root 2 times that is 2 root 2. Root 2 times root 2, 2. Is that the final answer? No, because you get factor out of 2. And then the 2's cancel out, and then your final answer is root 2 minus 1. That's a pretty nice answer. So for many of you, the hardest part will be simplifying, because all you gotta do is just follow the identity. It's not that hard. But the simplifying method might get you.
Wait, so what happens if you use 1 over root 2? Which that-
Oh, okay, what if you did use 1 over root 2 instead? Let's just say you had foresight. Then you just multiply top and bottom by the least common denominator, which is root 2, right?
Obviously, oh, I
And
see.
then look, root 2 times 1. Root 2 times 1 over root 2 is 1. And what's root 2 times 1 over root 2? 1. So that's the answer. See how, no, well, I can maybe save 2 steps there. It doesn't matter, sooner or later you're gonna get there. Okay, and then you're gonna have a couple proofs, so you guys know how to do that. But the last type of problem is just like the one I did on the board here, where you gotta draw the triangle in the proper quadrant. So they might say something like, tangent theta is equal to, give me a number.
What kind of number?
Shh. 24/7. Theta is between pi and 3. I see I'm coming up with a masterpiece right here. Compute. Okay, we didn't do sine yet. Sine of theta over 2.
Okay.
Okay, so I guarantee you this problem's going to be on the test right here. This problem's on the test. Okay, so the first thing you do, regurgitate that identity. Ah! Regurgitate it. It's right there.
Plus or minus.
Here, I'll point to it right there.
Plus or minus the square root of 1 minus cosine.
Yeah, so if you have the identity sheet right next to you, everybody here can do it, but it's gotta be here, man. And by Friday, it better be here, because on Monday is the test, and you have no notes on that, okay? So first thing is you gotta figure out that. Now, how did I tell you how to figure out whether to use plus or minus?
It's where it is.
You gotta look at the quadrant of this angle right here, theta over 2. Yeah, but Mr. Park, all I know is theta is between here and here. How do I figure out theta over 2? Well, what can I do to theta to get theta over 2? Divide by 2. So divide everything by 2. So if I divide everything by 2, you get this, correct? So theta over 2 is between pi over 2, here let's draw the unit circle, here's pi over 2, and 3 pi over 4, which is there. If you're between here and here, what quadrant is that?
Second.
That's in the second quadrant. What is the sine of a second quadrant angle? What's the y coordinate up here? Positive or negative? It's positive, so you go pick the positive one in this problem. 1 minus cosine theta all over 2. Now, how do I figure out what cosine theta is? Well, you have to draw this in the proper quadrant. Okay? So, if you're between pi and 3 pi over 2, you're in the third quadrant, right there. Tangent is what? Opposite over adjacent. And then Pythagorean theorem, what? 7, 24, 25. Now, if you don't know your Pythagorean triples, then just use the Pythagorean theorem. And then this one is minus and that one's minus, correct? We got 1 minute left. Okay, so look at this picture. What is cosine of theta? Cosine is adjacent over hypotenuse. So negative 7/25. So the key to doing these problems is you gotta take care of these signs, because every time you get a wrong sign, it's gonna be -2. -2, and they're gonna all add up. Now, some of you are thinking, Mr. Park, why do you make the answer come out ugly? No, I didn't, Moose Breath. It comes out really nice. Watch this. Watch this. 1 minus negative 7/25. Okay, so here, multiply top and bottom by what? What? That's not what it's called. 25. What's going on here? So you get 25 plus 7 all over 50. What is 25 plus 7? Quick. 32 over 50. Hey, I can reduce that to 16 over 25, but I can square root both of those numbers and you get, see, I told you I came up with a masterpiece.
You're still gonna put the color.
I'm probably going to give you this exact same problem on the test.
Number.
Yeah, because you know why? Because if I use this number, the noun comes out big. Or would you rather see an ugly radical? Alright, we'll see you, I guess, tomorrow, Wednesday. Is it extended?
Wednesday is the next
No,
day.
it is extended. Okay.
Faculty fallings are this week.
Faculty meeting, but you know what? For you, I'll let you do it after. Right after school.
Okay.
What about Lee?
Tomorrow, early in the morning.
Okay.
I will take a time.
Don't trust her.
Mr. Park, I think I turned in one of the wrong ones.
Yeah, your homework was delinquent, so. You had a my
Did I turn in a wrong one?
No, you handed it in, it was just missing.
It was just missing.
Yeah, so you had like a minus 15.
There were 5
Because that was 15 problems on that one, yeah.
Yeah.
So it was minus 15, so. All right.